if you have a current in a wire, there is going to be a magnetic field around it. This was discovered by Ampere. Ampere, and he did a great job. Like, for example, when you turn on the current in this wire, you can figure out that there is going to be an orientation of this magnets, the compass needles in a certain manner, which indicates that there is going to be a magnetic field around. And how do we know this? What is the direction of the magnetic field? Again, take your right hand, point the thumbs in the direction of the current. The direction of the fingers gives you the direction of the magnetic field, like what you see in this figure. Yeah, the thumb of your right hand, yeah, this is the right hand, that thumb is in the direction of the current, then the fingers give you the direction of the magnetic field. So in your lab 2, you'll be using something like this, where you'll have, instead of a line current, you're going to use coiled current there. It's called as a Helmholtz coil experiment, and that will be very fun. Yeah, which is what you're going to see here. Now, whatever that we said for a line current, this is a line current, whereas here this current is a loop current. So you have either a line or you have a loop. A loop current is going around in a circle. So when it comes to a loop current, again, the idea is simple. Yeah. So if you were to orient your fingers with the thumb pointing in the direction of the current, the thumb pointing in the direction of the current, then the fingers give you the direction of the magnetic field, which is exactly what has been captured here. Right? So to keep it simple, another way of viewing this is, when you have loop current, just when you have loop current, take your right hand finger, use the fingers in the direction of the loop, where the currents are flowing in. Then your thumb gives the direction of the magnetic field, which is quite counter to this guy, yeah, which is analogous to the here, because here thumb is the current and fingers are the field. This is I and this is B. Yeah, the other way around also works. Yeah, that means if you now have, instead of thumb being the current, you have thumb to be the direction of the B field and the fingers to be the direction of the loop current, because loop current goes around in a circle. Then if you go ahead and orient your right hand fingers in this direction, then you naturally see that your thumb will be pointing in this direction to the right. So your B field is going to be so you can swap technically. Yeah, if you have a line current, then it's thumb in the direction of the line current and fingers gives you the direction of the B field. If you have a loop current, then you have your fingers in the direction of the loop, fingers in the direction of the loop current, then the direction of the right thumb is going to be the direction of the B field. So there is a law that relates that, now that I know that there is a magnetic field around a current carrying wire, what is the value of that magnetic field here? That is given by the so-called Biot-Savart law. Just like when you had Q1, Q2 over 4 pi epsilon naught r square, that electric field, whatever be the direction, the magnitude of the electric field is going to be this manner.